Thank you and welcome to the Knowledge Center YouTube Distance Learning Project. Let's go with problem 2 of the 10 most interesting problems in advanced level physics mechanics. Hey everyone, welcome once more to our YouTube channel. So the problem we're checking out today is mechanics problem 2. That's the problem on the screen. So feel free to check it out. Feel free to attempt it. If you find any difficulties, go ahead and play the video and check what we have done. Let's go. So, hey guys, before we solve this problem, remember to check out the last problem on the last screen because that's going to be your assignment. So you attempt that problem on the screen and you try to upload your answers so that again we can have a preview of the next problem that comes up in the series of 10 mechanics interesting problems for advanced level. So let's check this one out. The student devises the following experiment to determine the velocity of a pellet from an air rifle. Plasticine is placed on the edge of a table such that it just fails to fall off. A pellet of mass m is fired horizontally into the plasticine and remains embedded in it. As a result, the plasticine reaches the floor a horizontal distance k away. The height of the table is h. Show that the horizontal velocity of the plasticine with pellet embedded is k into g by 2h 0.5. All right, this is a very interesting problem because again, it combines your knowledge of projectiles together with your knowledge of course, the law of conservation of momentum, which is basically Newton's second law. So yeah, it's your ability to solve things in tandem, right? So let's just go ahead and first of all draw the diagram and see what is really happening here. So you have the barrel, so you fire a pellet, right? And then it gets embedded into the plasticine here. And so together, because you fire it horizontally, of course, when the pellet gets embedded into plasticine, originally it's going to have a horizontal momentum, right? So the impulse is going to be in the horizontal direction, and so it's going to have an horizontal velocity in this direction to the red. So that velocity is also going to be the v common between the pellet and the plasticine. But because of gravity, the particle is actually going to follow a curved path like that, and so this is the trajectory of the particle after the pellet gets embedded into the plasticine. So the real interesting thing here is for you to understand that this is you're now dealing with projectile motion, and that is motion in two planes. So you can bring out the y plane and of course the x plane to be able to compute and come out with whatever you want to come out in that problem. So let's consider the vertical motion, right? Motion along the y axis. So of course, applying Newton's, of course, equation of motion, we're going to get displacement in vertical plane, which is just y, to be equals to uy times t. That's initial velocity in the y direction multiplied by t plus half gt squared. But what's initial velocity in the y direction? Remember that the particle just goes off horizontally like that. So initial velocity in the y direction is 0. Okay. So we can now go ahead and say that, all right, so the displacement in the vertical direction is basically half gt squared. Of course, because you're going downwards, right? So again, you're working for gravity. So that's why this guy is positive here. So we can make t the subject, and so that would give us time of flight to be 2h over g square root of that, right? Easy peasy lemon squeezy. So why do we have h here? Because again, the vertical displacement is basically h. That's why we're getting 2h here in place of y. So from x equals ut, now we're now dealing with the horizontal motion, okay? So in horizontal motion, we basically say x equals ux times t. Of course, since the acceleration in the horizontal direction is 0, that's why we don't add this extra term there. So we just have x equals to x times t. But remember that our u in the horizontal direction is the common velocity. So the pellet hits with the plasticine and then they get embedded. And so they move off with the common velocity v common. So that common velocity is vc. Then we have to multiply the time. There is basically the time of flight, which is what we just calculated up here. Because remember that for a projectile motion, the particle takes the same time to fall through this vertical displacement as it does through the horizontal displacement. So we can basically use one of these motions to calculate time of flight and then put in the other, which is what we've done here. So our horizontal displacement, which is x, is k, right? So that's why you see me putting k there. Horizontal displacement now, velocity is vc times time of flight. But what's our vc? Our vc now becomes k over time of flight. And when our time of flight is 2h over g, we can simplify that and then we get that our common velocity is basically k into g over 2h raised to the power 0.5. And that is our proof for the first part. Our next problem says we should be able to obtain an expression for the velocity of the pellet before impact with the plasticine. All right, so we're just going to again indicate what's happening. So the pellet has impacts with the plasticine and then they go off in that direction. Notice that the first problem is really just about this projectile part of the problem, right? Now, the second part of the problem now would require you to apply the law of conservation of momentum because again, let's look at these are two particles colliding. And so when they collide, of course, that's a particular closed system because again, the direction of application of law of conservation of momentum is independent to the direction of external forces. So yeah, that's a closed system interacting particles in terms of applying the law of conservation of momentum in the horizontal direction. So I can apply that law in the horizontal direction, and it's of course going to look like that. So momentum before collision, which is just the mass times the velocity of the pellet, so m small v, uh, yeah, equals. Now, what's the common momentum after I get embedded into this guy and I move off with common vc? It's basically the mass of the pellet plus the mass of the plasticine, which is m subscript p, multiplied vc. Okay, so this is the momentum after collision. The two of them gets embedded, so the total mass is m plus mp, then multiplying the common velocity, which is the c. Of course, we can get v, which is the velocity of the pellet, as basically dividing through by m, right? I mean, it's a consequence of the law of conservation of momentum right there. So we can simplify this and get our velocity of the pellet like that. But then what is VC? Remember that VC is K into G over 2H raised to power 0.5. So our K, our VC, we put back in the expression for V. Remember that this expression for V simply comes from the law of conservation of momentum. But you already know VC because you've calculated VC, which for Roman 1, right? The previous part. And so our V now basically is this is the expression for velocity right there. So if you know the horizontal displacement of the particle, you know the masses of each one of those particles. Of course, G is a constant, H, you know H, then you can easily get the speed with which the plasticine or the pellet, sorry, collides with the plasticine like that. So that's pretty much it, people. I hope you enjoyed this particular part of the question. Because again, this one was just teaching you how to deal with problems in tandem. That is solving a problem that that what demands your understanding of projectile motion in tandem with your understanding of Newton's second law, right? So that's it right there, people. Leave comments, subscribe, and please make sure you turn on the notification bell so you don't miss updates from our channel. But before I go, I'm also actually going to give you a problem, so you try that out, and then you can put the comment. You can comment down below the solution to the problem. Okay. So this is our problem right here. This is mechanics problem 3. You're going to see this in the next video. Just pause the video and see the problem and try to solve it, and then comment what your answer would be. Please, this mass here is actually 4.5 times 10 to the negative 7 kilograms. This 7 is up here, right? That's 4.5 times 10 to the negative 7 kilograms. Um, Again, just check out what you can do and comment down below. Thank you guys so much. Have fun. Take care.